It cuts down on your extraction efficiency and certainly cuts down on your recovery percents. Essentially what you want is a nice even flow through the disc so that you get a nice constant deposit of these chemicals that you're looking for on the disc. If you get it going too fast, if the flow is too fast, it will be too fast for the chemicals to bind with each other, and it will actually decrease your recovery levels. Now we're ready for disc drying. After you pull your solution through your reservoir and deposit all of your analyte on the disc, what you want to do is you want to apply maximum vacuum and then turn your system to wash and dry the disc for about 5 or 10 minutes at maximum vacuum. This is done primarily to get rid of all the water that could be trapped on the disc, which would adversely affect your recovery levels. Now we're ready for analyte elution. Essentially what you've done now is you've dried the disc. All your analytes are deposited on your disc, so you want to add a solvent to pull these analytes off the disc. In order to elute the analytes off the disc, you use the same solvent or a combination of solvents that you use in the wash step. Essentially what you do is add the solvents to the reservoir. It just then goes through the disc and elutes off the analytes that you're looking for into the collection vessel. Now you're ready for final analysis. Essentially what you've done is you've eluted off all your compounds of interest from your disc into your collection vessel. Now you want to remove your collection vessel, and you can perform any type of analysis that is required upon this particular sample. Method 1664, you would evaporate the hexane and do a gravimetric analysis. Methods 525.2, you would evaporate most of this solvent down and do a gas chromatograph mass spectrometry analysis. Other methods, you might evaporate this down or do a solvent exchange and perform a gas chromatograph electron capture detector analysis. So it really depends upon what particular method you're following as to what you could do with this final step. In conclusion, we hope we've offered you some helpful hints in solid phase extraction using CPI's disc and our new 7000 manifold. There are a few hints that we'd like to pass on to you. Number one, always make sure you have enough vacuum. We found that about a 1/3 horsepower vacuum pump is what is needed. You need to produce about 23 to 25 inches of mercury, particularly in drying the disc to remove all the water from the disc. Number two is use gravity filtration when possible, especially in the last stage, in the analyte elution stage. You want to use slower gravity filtration to actually remove the analyte from the disc. Number three is never let the disc go dry, especially when you're conditioning the disc with methanol. If you do let the disc go dry, you should then restart the whole procedure all over again at the wash step. Number four, and I can't stress this enough, although our disc and manifold are manufactured to allow maximum flow, sometimes slower is better, particularly in the last stage, the analyte elution stage, when you're removing your analytes from your disc. What you want to do is slow down this flow so that you get maximum extraction of the analytes by the solvent, and thus increasing your extraction efficiency and recoveries. From an application standpoint, I can tell you the CPI's disc and manifold are extremely user-friendly. In that regard, they allow the analyst to be in total control of the entire extraction procedure. In conclusion, Matt Norsky and I would like to thank you and remind you that you can reach us at our 800 number at any time.